Hi students, in the previous lecture we have learned introduction of inverse Laplace transforms and formulas, inverse Laplace transform of basic functions which depends upon the existed 7 denominators. Then later we discussed first shifting theorem on grouping terms as well as second shifting theorem when it is multiple by exponential function. In this lecture, we will discuss very important topic inverse Laplace transform of derivatives. I can give you in different manner of inverse Laplace transforms. See in this lecture, inverse Laplace transform of derivatives. What it says, L inverse of f of s is equal to f of t. Then L inverse of f n, nth derivative of s is given by minus 1 power n into t power n into f of t, minus 1 power n into t power n into f of t. This is actual formula. When you follow textbook without knowledge, there you can apply in different ways. Please don't follow the textbook. You follow my view. ILT by derivatives only you can allow for these occasions. What are the occasions? Inverse Laplace transform of logarithmic function or tan inverse or cot inverse. Then only we can allow inverse Laplace transform of derivatives. Otherwise you can go for any other method. See, if I want to find L inverse of log s minus 1 by s plus 1. Usually from the previous lectures we can get when log appears. How log appears? Laplace transform of divisible by t has given by either log or tan inverse or cot inverse. Did you get this point from the previous lectures? Same thing I am repeating here in reverse order. L inverse of log s minus 1 by s plus 1. So whatever it is there in the bracket, that I am going to take f of s. F of s is equal to log of s minus 1 by s plus 1. So log a minus log b. And no formula exists in terms of logarithmetic. That's why I am doing differentiation to vanish the logarithmetic function. So both sides differentiating. What is the log of s minus 1 derivative? 1 by s minus 1. What is the log of s plus 1 derivative? 1 by s plus 1. Now you apply L inverse on both sides. See, L inverse of 1 by s minus 1 is e power t by the formula number 2. L inverse of 1 by s plus 1 is e power minus t by the formula number 2. So come to the left hand side, L inverse of f dash s. So what is our formula? L inverse of nth derivative is given by minus 1 power n into t power n into f of t. Here n is equal to 1 na? Minus 1 power 1 into t power 1 into f of t. Here f of t is what here? E power t minus e power minus t by minus t. That is nothing but e power minus t minus e power t by t. So see the students here, whatever the logic we applied in Laplace transform of divisible by t, again repeated over here. Come to the problem number 2. Log of s minus 2 by s minus 3, same. Take f of s, log a minus log b, both sides to differentiate. So log of s minus 2 derivative is 1 by s minus 2, log of s minus 3 derivative is 1 by s minus 3. You apply inverse on both sides. So it can be given by like this. Please come to the problem number 3. L inverse of tan inverse of 2 by s. So f of s is tan inverse of 2 by s. No formula exists with the trigonometric, inverse trigonometric or trigonometric. So I want to vanish inverse trigonometric. So f dash s is equal to what here? Tan inverse derivative is what here? 1 by 1 plus x square and d by ds of 2 by s. The people are forgetting to write the derivative of 2 by s. Please be careful. So s square by s square plus 4. What is the 1 by s derivative? Minus 1, 2 by s square. S square cancel. What is left? 2 by s square plus 4. So now you take L inverse on both sides. Similar manner, left hand side we can get minus t e power minus t f of t is equal to minus 2 sin 2t by 2. 2 cancel, f of t is equal to what here? Sin 2t by t. Morning I told you as formula number 9 in previous lectures. L of sin t by t is equal to tan inverse s. Like this same way. So here L inverse of cot inverse of s plus 3 by 2. f of s is equal to cot inverse of s plus 3 by 2. What is the cot inverse derivative? Minus 1 by 1 plus x square. So minus 1 by 1 plus s plus 3 by 2 whole square, and derivative of s plus 3 by 2. What is the derivative of s plus 3 by 2? 1 by 2. Here 2 cancel. So this is there. Please observe here, it is grouped term I can get by first shifting theorem. So here plus 3 is there, now plus 3 come out as e power minus 3t. Whatever the leftover portion, 1 by s square plus 2 square. This is I can write sin 2t by t. Here minus t into f of t. Finally f of t is equal to e power minus 3t into sin 2t by 2t. So from this page we can get a clear clarity that inverse Laplace transform of logarithmic or tan inverse or cot inverse only allowed under ILT by derivatives. So next, inverse Laplace transform by partial fractions. Very important and general method is called inverse Laplace transform by partial fractions. Here every student knows from your intermediate second year 2a partial fractions. 1 by x plus a into x plus b, I can write a by x plus a plus b by x plus b. This is the repeated real root, I can write a by x plus a plus b by x plus a whole square. Suppose 1 by x plus a whole cube is there, I can get plus c by x plus a whole cube. So non-repeated real roots are there, non-repeated quadratic roots are there, I can write ax plus b by x square plus a square plus cx plus d by x square plus b square. But usually I am observing a common mistake is, here we are dealing with s. In examination some people are writing ax plus b. Please don't write, we can write as plus b. It's common mistake I am observing in the evaluation part. See, in the previous lectures, wherever I am dealing with change of scale property, that time directly L of f of t is given. That means f of s is given. We calculated L of f of 2t. But no student gets doubt over there. Did I retrieve f of t from that? Yes, we can retrieve f of t from that by inverse Laplace transform. There I couldn't speak about that point because we don't have knowledge on inverse Laplace transforms at that moment. See question number 1. L inverse of 1 by s minus 1 into s minus 2. 1 by s minus 1 into s minus 2 is what? How you can factorize here? A by s minus 1 plus b by s minus 2. Take LCM. Here every student have knowledge on partial fractions. You complete your partial fractions only. 1 is equal to a into s minus 2 plus b into s minus 1. So put s is equal to, I can get b value. Put s is equal to 1, I can get a value. Then substitute here. Finally, L inverse of 1 by s minus 1 is e power t. L inverse of 1 by s minus 2 is e power 2t. Come to the problem number 2. These are the non-repeated linear factors a by s plus b by s minus 2 plus c by s minus 3. Then you can go for LCM. This is there. One time put s is equal to 0, I can get a value. Put s is equal to b value, c value. Put s is equal to 3, I can get b value. Finally, whenever you are writing ABC values, then you apply inverse Laplace transform on both sides. It comes from any one of the above existed formulas, either direct 7 or first shifting theorem or any other one. So see here, all of you, here also denominator have non-repeated linear factors a by s plus 1 plus b by s minus 2 plus c by s minus 3. Put s is equal to 2, we can get b. Put s is equal to 3, we can get c. Put s is equal to minus 1, we can get a. By writing ABC over here, then later we apply inverse Laplace transform on both sides. We can get 1 by 6 e power minus t minus 4 by 3 e power 2t plus 3 by 2 e power 2t. Next, see very important model, s by s square plus a square into s square plus b square. These are the non-repeated quadratic factors. I can fractionize into as plus b by s square plus a square plus cs plus d by s square plus b square. Students, here some people are writing ax plus b. Please don't write as plus b. Then take LCM on both sides. in earlier page all are the linear roots, that's why we substituted and get the values of a, b, c, d. But here it is not possible because here square term is there. Then simply you multiply and write decreasing powers of s power 3, s square, s constant. Write the decreasing powers of s. Comparison on both sides. What is the s cube term? A plus c equal to 0. S square term b plus d is equal to 0. Then s term small capital A into b square plus capital C into small a square is equal to 1. Then constants, when I compare, b into small b square plus capital D into small a square is equal to 0. See, equation number 2 and 4 you observe here, it is there in terms of b and d, but both having zeros. These are the homogeneous system. It gives b equal to 0, d equal to 0. So these are over. When you take first and third, you solve, we relate a and b values. A is minus 1 by a square minus b square. B is 1 by a square minus b square. See, substitute over there. What is left? S by s square plus a square means cos at. S by s square plus b square means cos bt. In the similar manner, you people observe here 1 by s square plus a square into s square plus b square. It can be written as as plus b by s square plus a square plus cs plus d by s square plus b square. The same way you can apply and we can get the values. That's the generalized method for finding inverse Laplace transforms by partial fractions. So now next topic is inverse Laplace transform of multiplication by s power n. See here, if L inverse of f of s is equal to f of t, then L inverse of multiple by s power n is given by derivative of f of t. But dear students, please don't follow this method because L inverse of s by s square plus 1 is there. I can write directly cos t. Suppose anyone asks in 2 marks L inverse of s by s square plus 1, usually you are writing cos t for 2 marks. If you don't write like that, you want to give a clear solution, it should be written as s into 1 by s square plus 1. What is f of s? 1 by s square plus 1. Whenever you apply inverse on both sides, 1 by s square plus 1 is what here? Sin t. So then what is the formula? Here d by derivative of f of t. It is not there, ma. It is wrong. So derivative of sin t is what here? Cos t. By this way you can get, or else that L inverse of s by s square minus 4. Everyone knows it is cos h2t. Otherwise you can get like this. This is ILT by multiple by s power n. So if you want to remember, otherwise you can get by other general method. ILT by divisible by s. See, if L inverse of f of s is equal to f of t, then L inverse of f of s by s is equal to integral 0 to t f of t dt. From the lecture number 3, Laplace transform of integrals is given by divisible by s. Here, same thing, inverse Laplace transform of divisible by s is given by integrals. But students, here, no need to remember this formula because divisible by s is nothing but in denominator multiple of 2 terms. A multiple of 2 terms can handle very easy manner by partial fractions. Am I correct or not? Partial fractions is there na? How should you write? This is a by s. See, a by s plus bs plus c by s square plus 1. If you go that way, sir, I want to give the correct method, I want to implement the correct method genuinely, means you write like 1 by s square plus 1 by s. What is f of s here? 1 by s square plus 1. So that is sin t. So L inverse of f of s by s is what here? Integral 0 to t sin t dt. Sin t integration is what here? Minus cos t. From 0 to t. Then its value is 1 minus cos t. Either you go by partial fractions or by this. Anything will give same. But it's your choice. ILT by integrals. In L inverse of f of s is equal to f of t. Then L inverse of integral s to infinity f of s ds is equal to f of t by t. From the lecture number 3, Laplace transform of divisible by t is given by integral of f of s. Here L inverse of integrals is equal to divisible by t. See, please look at here. When I go for cross multiplication, here f of t is equal to what should I write? T into L inverse of integral 0 to integral s to infinity f of s ds. But you people remember here, what is f of t? F of t is nothing but L inverse of f of s. In other way of representing this is L inverse of f of s is what here? T into L inverse of integral s to infinity f of s into ds. So this one also no need to remember except this occasion. See, L inverse of integral s to infinity log of s minus 1 by s plus 1 into ds. When you observe L inverse of s to infinity, definitely it can obtain by this method only. Whatever there here rounded by circle, that is f of s, you get f of t by Laplace, inverse Laplace transform of derivatives. So I couldn't repeat the same solution from the previous page. So here f of t we can get e power minus t minus e power t by t. Whenever you come down to this formula, it is f of t by t. Already another t is there, I can get by t square. So whenever L inverse of integral s to infinity, log term or tan inverse or cot inverse, we can apply this manner. Means indirectly nothing is there in this solution. If people remember, log or tan inverse or cot inverse exists, we can get from ILT by derivatives. Later we can divide with t. That's enough. In sometimes L inverse of s plus 2 by s square plus 4s plus 8 whole square. This problem is there. Whenever the people may observe this problem, they are without any knowledge, they can start with partial fractions. This is a repeated quadratic form. They may write as plus b by s square plus 4s plus 8 plus cs plus d by s square plus 4s plus 8 whole square. But instead of that, no one can give this kind of thing for 5 marks. Use logic. What is there? S plus 2 by s square plus 4s plus 8 whole square. Na? You can call this formula. This bracket is f of s. This is I can write t into L inverse of integral s to infinity s plus 2 by s square plus 4s plus 8 whole square ds. So its derivative is what here? S square derivative is 2s, 4s derivative is 4. To get that, multiply and divide with 2. What happens here? This formula f dash x by f of x whole power n into dx, that we can write f of x whole power minus n plus 1 by minus n plus 1. Using that formula, so upper limit is what here? This is denominator now, something by infinity is 0, lower limit is minus or minus plus. So what is there? T by 2 into L inverse of 1 by s square plus 4s plus 8. It can get by first shifting theorem. We can write into s plus 2 whole square plus 2 square. S plus 2 is e power minus 2t L inverse of 1 by s square plus 4. That can be given. So these all are the methods of inverse Laplace transforms. In this lecture we covered inverse Laplace transform by derivatives, inverse Laplace transforms by general method like partial fractions, inverse Laplace transforms by multiple by s power n, divisible by s, ILT by integrals. But this phase only occasionally you apply, otherwise these also comes from previous pages. So in the next class we will cover another topic. Thank you.